Hello everyone, I welcome you all in the C programming and data structures lecture. This is part 8 of application of stacks, infix to postfix conversion. So without any further delay, let's get started. In this presentation, we will learn how to write a program to evaluate the postfix expression. In the previous presentation, we have seen how to convert an infix expression to its equivalent postfix form. Now in this presentation, we will learn how to write a program to evaluate that postfix expression, okay? We'll take the example of the previous presentation only and we'll try to evaluate that postfix expression. So without any further delay, let's move on. We know that this is the algorithm and we know that this algorithm is capable enough to evaluate the postfix expression. These are just plain English sentences. Of course, we have to write an equivalent C program for this algorithm, right? We have to scan the symbols of the given postfix expression from left to right. This is our target, and for each symbol, we have to do the following. If symbol is an operand, we'll push it onto the stack. If symbol is an operator, we'll pop two symbols out of the stack and apply the operator on these symbols. Then we have to push the result on the stack. Very simple procedure, right? After scanning all the symbols of the postfix expression, we have to pop the remaining symbol. Just one symbol we're left with at the end. We have to pop that out of the stack and then print it onto the screen, right? The remaining symbol is the result obtained after evaluating the postfix expression. Okay, that's what we will do. Let's try to convert this algorithm to its equivalent C program. But before that, we have to see our main function, right? But it's important to see the infix to postfix expression as well. In the previous presentation, we have seen the infix expression. This is the infix expression 7 plus. We have these opening parentheses, then 9 minus 5, then closing parentheses, then star and 2, right? This was the infix expression we have seen in the previous lecture. And this is the equivalent postfix expression of this infix expression 795 minus 2 star plus, right? We'll deal with this postfix expression in this lecture and we'll try to evaluate this expression, right? And we will try to obtain the result which is equal to the result obtained from the infix expression. For this purpose, of course, we need a main function, and in this main function you can see I'm asking the user to enter the infix expression. User will enter the infix expression. Then after this, I'm calling into post function for the purpose of converting the infix expression to its equivalent postfix form. Think of this as a black box. And here, we don't know how this function works, but it will return the equivalent postfix expression for the infix expression provided to it, right? After this, we'll print the result onto the screen. That's what we have seen in the previous presentation, right? Now, this is the main function. But there is one more thing that we have to look into. Actually, we want to change the type of this stack array. It is better to make this an array of integers, as this time we want an operand stack and not the operator stack. Way back we need a stack which will hold all the operators. That's why it was called operator stack, right? But now this time we need an operand stack. This means we want to store all the integers into it, right? And it is important to understand that we can actually change the type of this array. There is no problem in doing that, even though our into post function will work fine in that case as well, because we know that eventually the character can be treated as an integer and later on we can manipulate them in our code. There's no problem in doing that, right? That is why it is better to make this an integer and not a character, right? This will not create any problem in the conversion of infix to postfix expression. You can check this on your own. This will not create any problem. You can treat a character as an integer and later on you can manipulate it. There's no problem in doing that, right? Therefore, it is better to make this type an integer. So let's make it an integer. And then after this, of course, we need these two things. That is one variable and of course this line of code. That is result equal to post eval. Actually, I'm calling the post eval function for the purpose of evaluating the postfix expression. Here, the result returned by this post eval function will get stored inside this result variable. This is the actual result obtained from the post eval function. After evaluating the postfix expression, we will get just one value and we'll store that into the result variable. Okay. Now let's see the algorithm. Scan the symbols of the given postfix expression from left to right, and for each symbol do the following. Okay, we have to scan the symbols of the given postfix expression. This means we are dealing with postfix array and we have to scan all the symbols of the postfix array, right? For this, in the post eval function, we have to write this for loop which runs from I equal to 0 to I less than string length of postfix. I hope this is clear. We know that how to calculate the string length of the postfix array. We just have to pass the postfix array to the string length function. That's it, right? And passing the name of the array means that you are passing the whole array to the function, right? After this, the next step is that if symbol is an operand, then push it on the stack. Simple. If symbol is an operand, then push it on the stack. So we'll check this condition. If postfix of I is greater than or equal to character 0 and postfix of I is less than or equal to character 9, then push it onto the stack. Okay? Simply push postfix of I onto the stack. Now you might be wondering why I'm checking this condition. Why I'm doing like this? This is a character and not an integer, right? How is it possible to compare a character with a character? Let's try to understand how this code works. If first I is initialized to 0, as you can see this over here, after this I'm checking this condition, is I less than string length of postfix or not? String length of postfix returns 7, isn't that so? As you can see, there are 7 characters in this postfix array, excluding this null character. Please don't include this null character. This strlen function will always return the number of characters of the string, excluding the \0 or null character. Fine? So here we know this will get replaced by 7. And I is less than 7, therefore we'll get inside this for loop. If postfix of I is greater than or equal to character 0 and postfix of I is less than or equal to character 9, then we can continue, right? Let's see what is postfix of I. We know that postfix of I is this character 7, right? We are trying to compare this character 7 with character 0 and character 9. That's what we are doing here, right? We know that postfix of 0 is character 7. And actually we are trying to compare it with character 0 and character 9. But how to do this? We have to see the ASCII codes of all the characters for this purpose. We know that the ASCII code of character 0 is 48, ASCII code of character 1 is 49, and it goes on in this way. There is a sequence maintained every time. This is just one step increment: 48, 49, 50, 51, 52, 53, and so on. You can see the ASCII code of character 7 is 55 and ASCII code of character 0 is 48. Right? So actually we are comparing their ASCII codes, isn't that so? We know that character 7 is greater than or equal to character 0. Don't see them as characters, see their ASCII codes. You know that the ASCII code of 7 is 55. So we can replace this by 55. And ASCII code of character 0 is 48. So we can replace this by 48. And we know that 55 is actually greater than 48. Therefore this condition is satisfied. Apart from this, we also know this that character 7 is less than character 9. You can see this over here. ASCII code of character 7 is 55 and ASCII code of character 9 is 57. Definitely it is the case that the condition is satisfied, right? This condition is definitely satisfied. There's no problem in this. And after this, of course, we'll get inside this if construct and we will push postfix of I into the array. This means character 7 will be pushed onto the stack, right? So we can see one character, that is character 7, inside this stack. But we don't need this, isn't that so? We should store an integer 7 and not character 7. We should understand this, that this is an operand stack and not the operator stack. Apart from this, it is important to understand that we want to store integers and not the characters. Okay? Because eventually we want to evaluate this whole expression. We want to perform the operations on these values, right? Therefore, it is important to store the integers and not characters. But how to obtain the integer 7 from this character 7? How to extract integer 7 from this character 7? Let me ask this question. What is character 1 minus character 0? What is the result of the subtraction of these two characters? Again, ASCII code came into picture. Here we know the ASCII code of character 1 is 49 and ASCII code of character 0 is 48. So it is nothing but 49 minus 48, which is equal to 1. We can say that character 1 minus character 0 is 1. Okay, that is making sense. Now what about character 3 minus character 0? ASCII code of character 3 is 51 and ASCII code of character 0 is 48. So this is nothing but 51 minus 48, which is equal to 3. So actually the result of character 3 minus character 0 is 3. Now I hope it is clear to you that what is the result of character 7 minus character 0. It is definitely 7, right? So we would be able to extract 7 from this character 7 after subtracting it from character 0. Therefore, in this case, we have to subtract postfix of I by character 0. Okay? So instead of pushing postfix of I, we will push postfix of I minus character 0. Now it is making sense, right? So we're done with the first part, isn't that so? And here you can see integer 7 is pushed and not the character 7. We are done with this part. If symbol is an operand, then we'll push it onto the stack, the integer equivalent of the character and not the character itself. What happens if symbol is an operator? What to do in that case? If symbol is an operator means we have to put all the different cases. This means which case is again required? First of all, else part is required, because if the symbol is not an operand, then it will be an operator, right? Then in that case, pop two symbols out of the stack and apply the operator on these symbols, right? And then push the result on the stack. For this purpose, we need to call pop twice. Here, I'm storing the result of the topmost element of the stack in this variable A and the second topmost variable inside variable B. So we have these two variables, A and B, and they are actually integer variables. Here I'm storing both the integers, the topmost elements of the stack in A and B. Fine. After this, switch case is required. As I have already told you, we need a switch case and these multiple cases. As you can see this, it is important to compare the current operator with these cases, right? If postfix of I is an operator, then we will see which case is applicable here. Is that a plus operator, a minus operator, a multiplication operator, a division operator, or a power operator? We have to check all of them. If it is a plus operator, then we will push B plus A onto the stack. That's what we have to do according to the algorithm, right? If it is a minus operator, then we will push B minus A. Please note this is not A minus B, B minus A. We know this already why we are doing B plus A, B minus A, B star A, right? It is important that we have to do in this way, not the other way around, okay? So here we have a subtraction operator, we have a multiplication operator, here we have a division operator, so therefore we'll perform division over here. After this, we have a power operator. So here we'll push pow of B comma A. This function is available in the math.h library. We have to include that library in our code as well. Okay. This pow function is called for calculating B to the power A. Fine. We have to pass B comma A to this pow function. After this, the last step is to return pop. This means return the remaining element of the stack, right? After completion of this for loop, we have to return pop from this function. Now the first step is we have to initialize I by 0. We know that I is initialized to 0. Now we'll check, is I less than string length of postfix? Yes, of course. String length of postfix is 7. And I is less than 7. Therefore, we can continue. If postfix of I is greater than or equal to 0, character 0, and postfix of I is less than or equal to character 9, then continue. For now on, you can consider this as this is an integer 0 and this is integer 9. And you're comparing an integer with an integer. Okay, this would be easier. We know that postfix of I is 7, right? Character 7 is greater than 0 and character 7 is less than 9. Or you can see this like in this way. Or you can imagine this like 7 is greater than 0 and 7 is less than 9, right? Imagine these as integers. Now after this, of course, we can call the push function to push postfix of I minus 0. This will give us the integer 7. And definitely we would be able to push that integer onto the stack, right? After this, the next step is to increment the value of I by 1. This becomes 1. Then we'll again check this condition. Is 1 less than 7? Yes, of course, 1 is less than 7. Therefore, we will get inside and we'll check again this condition. Postfix of I is greater than or equal to 0 and postfix of I is less than or equal to 9. Now, what is postfix of I in this case? I is 1, okay? You can see this over here that postfix of I, that is postfix of 1 is 9, this character 9, right? And we know that this condition is satisfied, therefore we'll get inside and we would be able to call the push function for the purpose of pushing integer 9 onto the stack. You can see the current status of the stack, 9 is pushed onto the stack. Now the next step, again, I is incremented by 1, this becomes 2. Again, we'll check this condition, we know that condition is satisfied. If postfix of I is greater than or equal to 0, and postfix of I is less than or equal to 9, then we will continue. This is 5 and we know condition is satisfied. Therefore, we will push 5 onto the stack, right? Now the next step. Again, I is incremented by 1. This becomes 3. Condition is again satisfied. We'll land again at this line of code, right? This time we have encountered this symbol, this minus symbol. Okay, this is an operator. Therefore, else part will get evaluated. Isn't that so? Here we will pop the topmost element and the second topmost element of the stack and we will store them in A and B variables respectively, right? The topmost element will be stored at variable A and the second topmost element will be stored at the variable B. As you can see this over here, this is the topmost element and this is the second topmost element, right? Topmost element will get stored inside variable A and second topmost element will get stored inside variable B. Right? So A and B are 5 and 9 respectively. After this, we have the switch case. We know this, right? Postfix of 3 is minus. Therefore, this case will be evaluated, which means push b minus a. What is b minus a? 9 minus 5, which is equal to 4. Therefore, we'll push value 4 onto the stack. Okay. Now, what's the next step? Next step is to break out of this switch case, which means we will land at this point, that is I plus plus. Let's increment the value of I by 1. This becomes 4. Condition is again satisfied. We will land at this line of code, that is if postfix of I is greater than or equal to this character 0 and postfix of I is less than or equal to character 9, then we'll continue. Let's see this. What is postfix of I? Postfix of I is this character 2. Yes, of course, this is greater than or equal to 0 and less than or equal to 9. Therefore, we can push this onto the stack. Now, the next step is to increment the value of I. This becomes 5. Again, condition is satisfied. We'll get inside. Let's again check this condition. This time we have an operator. Therefore, we know that this element will be popped out of the stack and will get stored in variable A. This element will also get popped out of the stack and will be stored inside this variable B. Now we know that we have to multiply these two operands, that is 4 and 2. As you can see this over here, we have to push B into A onto the stack. What do we mean by B into A? B into A means 4 into 2, which means that we will push 8 onto the stack, right? Now the next step is to simply break out of this case. We'll land at this point, I is incremented by 1. We'll check this condition, 6 is less than 7, right? We'll continue, and in this case, of course, this condition is not satisfied. You can see this over here that we are dealing with a plus operator and not an operand, okay? Therefore, else part will be evaluated. And in this case, we are talking about a plus operator. And after this, of course, we'll pop two elements out of the stack. These are the two elements, 8 and 7. 8 will get stored in variable A and 7 will get stored in variable B. After this, we have to add these two variables, right? This case will be evaluated, which means push B plus A. What is B plus A? B plus A is 7 plus 8, which is equal to 15, right? So 15 will be pushed inside stack. Now the next step is, of course, to break out of this case and land at this point. I becomes 7. 7 is not less than 7. So we will get outside of this for loop. Isn't that so? And after this, of course, we will return pop. That is, we will pop the topmost element of the stack and will return that value back to the function, that is caller. So here, this value will be popped because this is the only element we are left with. And definitely, after popping this value will be returned back to the caller. And this simply means that we will receive this value in this result variable of this main function. Fine. This result variable will get this value 15. This value is obtained after evaluating the postfix expression. Now the next step is, of course, to print this result onto the screen. As you can see this over here, I'm printing this onto the screen. First, I'm printing this message. The result obtained after postfix evaluation is result. Fine. Let's say the user has entered this infix expression 7 plus 9 minus 5 into 2. Then eventually he or she would be able to see these messages. The equivalent postfix expression is 795 minus 2 star plus. The result obtained after postfix evaluation is 15. Fine. I hope the whole idea is clear to you. Now let's see the complete code in code blocks. Here you can see this is the complete code. I have marked the changes over here. You can see that the type is changed. Here also the type is changed. You can see this that this push function will now receive an integer and not a character. And here also the return type of the pop function has changed. You can see this. Now we have changed this to an integer instead of a character. Rest of the things are same. We have a main function. Here first I'm asking the user to enter the infix expression. I'll get the infix expression using gets function. And then after this I'll call the into post function for the purpose of converting infix expression to its equivalent postfix form. And definitely after this I'll call post eval function for getting the result. That is, after evaluating the postfix expression, what would be the result? We'll simply store that result inside this result variable. Then we have the print function. I'm calling the print function for the purpose of printing the postfix expression, and then I'm calling this printf function to print this message. The result obtained after postfix evaluation is result. Fine. This is the into post function. Space function, precedence function. Then we have print function to print the postfix expression. Then we have push function. You can see the changes over here. This will receive an integer value and not a character. Okay. And here in this pop function, the return type is integer. And here we have an integer val instead of character val. Then we have isEmpty function, power function. Although this is not required, I have created my own function, but you can actually get the power function from the math.h library. Okay, this is not required. Here I have included math.h header file as well. Here we have post eval function. And here you can see this, I'm using pow function, right, which is available in math.h header file. You can see the complete code over here, right? Now let's execute this code. Let's enter the infix expression. This is the infix expression. You can see the equivalent postfix expression is 795 minus 2 star plus, and the result obtained after postfix evaluation is 15, right? This is working fine, isn't that so? This time, let's say I want to enter this expression. Let's say this is the expression. You can see the equivalent postfix expression is 955 divide plus, division has to be performed before addition, right, of course. And then we have 97 star plus. The result obtained after postfix evaluation is 73. We know that 5 divided by 5 is 1. And of course 9 into 7 is 63, right? So 9 plus 1 is 10 and 63 plus 10 is 73. Therefore, the result obtained after postfix evaluation must be 73, and we have obtained this result, 73, right? I hope the whole idea is clear and our code is working fine as well. Let's see some drawbacks of the program and improvements that we can make. First thing is that code works only for single digit operands. Actually, this is a challenge if we can work out with multiple digits as well. The code actually works only for single digit operands. Second thing is, for simplicity, we have considered that the associativity of all operators is left to right. But in reality, this is not the case. The power operator actually has the associativity from right to left, not left to right. So we can write a code according to that. And of course, in the code, we can include one more function for the purpose of checking the associativity. Now this is up to you. You can write a code for checking the associativity of all operators as well and evaluate the expressions according to their associativity. Okay friends, this is it for now. Thank you for watching this presentation.